Check out this famous photo of the Earth. How would you describe the atmosphere? Thin. Half of the atmosphere is within 3.8 miles of the surface, and 98% of the Earth's atmosphere is held within just 16 miles of the surface. The Earth is nearly 8,000 miles in diameter. The atmosphere is a very thin, fragile layer around the Earth. So what is the atmosphere made out of? Air. Well, yes. But what is the air made out of? Well, there are gases and particulates. Particulates are tiny solid or liquid droplets that are so small that they are suspended in the air. And we'll talk about particulates later. The gases are what we're interested in now. And most of our atmosphere is made up of just 3 gases. You should be able to name them and note their approximate percentage. Nitrogen, present as N2 gas, is about 78%. Oxygen, present as O2 gas, is about 21%. And argon gas is about 0.9%. Together, that's over 99.9% of the atmosphere. So all the other gases we will discuss, carbon dioxide, sulfur dioxide, pollutants of all sorts, exist in minute amounts, though they are still important even in those small amounts. Interestingly, the atmosphere is 78% nitrogen, and all plants and animals need nitrogen. Do they get it from the air? Think back to the nitrogen cycle. What are the only organisms that fix nitrogen directly from the air? How do plants take in nitrogen? How do animals take in nitrogen? This table shows the principal gases of the atmosphere as well. Some gases stay in fairly fixed percentages, like nitrogen, oxygen, argon, neon, helium, etc. But some of the minor gases are variable over space and time. For instance, water vapor might be higher in coastal regions than inland regions. And here in California, it might be higher after a winter rainstorm than in the middle of the summer. So all these gases here, some of which are pollutants, are variable. They change by location and by time. The Earth's atmosphere has a layered structure, and we typically refer to 5 layers. Starting at their surface and moving upward, we have the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. We touched on this way back when we studied ozone depletion in the stratosphere. Our current discussion of air pollution and climate change deals only with the lowest layer, the troposphere. Notably, the layers are determined by their temperature profiles. Study the graph and notice how temperatures change in the troposphere and the stratosphere, and how their temperature changes are different. Where is the troposphere the warmest? Where is it the coolest? Pause the video and check it out. The troposphere is heated by the Earth, and thus gets colder as elevation increases, basically as the air gets farther from its heat source of the Earth. How about in the stratosphere? Does temperature continue to rise as you go up in the stratosphere? Pause this video and check it out. Temperature increases as you go up in the stratosphere. The stratosphere is heated by the sun, or actually by ozone-absorbing solar radiation. Thus, temperature increases with elevation. Our topic this week is air pollution. But before we dive into that, let's consider the importance of air as a resource. How many reasons can you think of why air is an important resource? Pause the video and list some. Hopefully you were able to come up with most of these. Pause the video and carefully read through the list. Next, of course, some definitions. Air pollution can be defined as any addition to the atmosphere, naturally or by humans, that harms living organisms, affects the climate, or impacts structures. Importantly, we also categorize pollutants as either primary or secondary pollutants, based on where they form. Primary pollutants are pollutants that are released directly into the atmosphere from mobile or stationary sources. Secondary pollutants are pollutants that are formed when primary pollutants react with each other, or when they react with other substances that are already in the air. Infographic 20.2 shows examples of some primary and secondary pollutants. Many of the air pollutants we will study are primary pollutants: sulfur dioxide, nitrogen oxides, carbon monoxide, carbon dioxide, particulate matter, etc. They are all released directly into the atmosphere from a source. The source can be a stationary point source, like a power plant or a volcano, or the source could be a stationary non-point source, like all the millions of little home chimneys around, or it could be a mobile non-point source, like cars. Secondary pollutants, on the other hand, form in the atmosphere as primary pollutants react with one another and with substances already present, like water vapor. Tropospheric ozone is a great example of a secondary pollutant, as it forms as nitrogen oxides react with oxygen and/or volatile organic compounds in the presence of sunlight. Acids like sulfuric acid and nitrous acid are also secondary pollutants, as they form when sulfur oxides and nitrogen oxides react in the atmosphere with water vapor. The Clean Air Act gave the EPA the right to set national ambient air quality standards for 6 criteria pollutants. Thus, there are standards that all regular ambient air across our entire country must meet for these 6 pollutants. If a location exceeds any of these standards, they are in non-compliance. I encourage you to memorize this list. These are some of the most important air pollutants. So here are the actual National Ambient Air Quality Standards for the 6 criteria pollutants. I obtained this table off the EPA website. You can see that for each criteria pollutant, there are primary and secondary standards. Primary standards provide protection for human health, including protecting the health of the most sensitive population, such as children and the elderly. Secondary standards provide public welfare protection. That includes protection against decreased visibility, damage to animals, to crops, to vegetation, and to buildings. Table 20.1 in your textbook shows a listing of the criteria air pollutants. I'm not going to read through this whole table in the video clip, but you should. You should be able to list the 6 criteria pollutants, and for each pollutant, you should be able to give a general description, perhaps some examples, and importantly, sources for that pollutant, both point and non-point source ideally, and also identify and describe the environmental and health impacts related to that pollutant. For now, we'll briefly go through this list and highlight some concepts that students often miss or get mixed up. First, importantly, carbon monoxide, CO, is a criteria pollutant. Carbon dioxide, CO2, is not. Though the EPA does have the right and duty to regulate CO2, we will discuss CO2 later when we talk about climate change. For now, we're talking about carbon monoxide, which is a criteria pollutant that interferes with our red blood cells' ability to transmit oxygen. It's hazardous to our health and can kill us directly. Carbon monoxide is created when fossil fuels are burned, and you can see here that cars and other vehicles are the primary source. For sulfur dioxide, the primary source is coal-burning power plants. When you hear of clean coal, sulfur dioxide is one of the pollutants that they are trying to reduce. They do this in part by putting scrubbers and/or electrostatic precipitators on the smokestacks at coal-burning power plants. Sulfur dioxide is also one of the primary causes of acid rain. Nitrogen oxides are very reactive and can be present either as NO or NO2, so we commonly just say NOx or NOx. Nitrogen oxides are nasty. They cause so many problems. They are a primary component of smog, and they damage our lungs. They can also damage plants, and they contribute to acid rain. Further, they help form tropospheric ozone, and they can lead to eutrophication of aquatic ecosystems. Cars are the primary source, as you can see here, but fossil fuel-based electricity generation contributes too. That's what's meant here by utilities. Ground level or tropospheric ozone is our fourth criteria pollutant. Don't confuse this with the good stratospheric ozone that forms naturally up in the stratosphere and blocks UV radiation. What we're talking about here is tropospheric ozone that is anthropogenic in nature. It's created by humans and is a terrible pollutant. Notably, tropospheric ozone is a secondary pollutant. It's formed from NOx, nitrogen oxides, and oxygen and other volatile organic compounds combining in the presence of sunlight. When we have a spare the air day here in the Bay Area, which means we are likely out of compliance or nearly out of compliance with our ambient air standards, ozone is usually the culprit. Ozone damages our lungs, and it damages plants as well. Since ozone is formed from NOx, nitrogen oxides, cars, again, are the primary culprit. Have you noticed a trend with the first four of these criteria pollutants? What are the sources of the pollutants? In general, cars, 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 cars. If we could just drive less and or use less gas or use electric cars, we would dramatically improve our air quality. Particulate matter, or particulates, are tiny solids or liquids that are so small that they remain aloft in the air. Fossil fuel combustion, from cars or power plants, contributes, as do construction sites. But here in California, agriculture is a huge source as well. As we don't get much summer rain, with the soil plowing, the soil blows aloft. Fires are also a large source in California's summers. California has some of the highest asthma rates in the country. Cars and agriculture play a big role in that. And temperature inversions can make things even worse. Notably, not all particulate matter has the same adverse health effects. Particulates that are less than 2.5 microns in size are the most damaging. Lastly, lead. Lead is definitely a success story. We've managed to reduce it by over 99% since the onset of the Clean Air Act, and we're still making improvements. Why has it gone down so much? Well, primarily because we've eliminated lead in gasoline and also eliminated lead in most paints. It's rare for a location to be in non-compliance with lead pollution, but there are places around mining sites and also in Southern California that still are sometimes in non-compliance.